Galileo versus Aristotle, the birth of modern physics. When Aristotle's armchair met Galileo's inclined plane, physics traded robes for lab coats and never looked back. Number 5. The Trial of Ideas. Before the judge's gavel ever echoed, the real courtroom was the Republic of Ideas. Aristotle's venerable system sat in the witness box while Galileo's method cross-examined tradition with experiments and math as evidence. The natural place, doctrine and tidy celestial spheres faced a barrage of data, moons misbehaving around Jupiter, projectiles tracing curves, and time measured on ramps. Though Galileo's 1633 trial dramatized the clash with orthodoxy, the deeper verdict was methodological. Authority and syllogisms couldn't overrule reproducible results. Controversy made Galileo the headline, but the legacy is a method. Hypothesize, quantify, test, repeat, an approach so stubbornly effective that even the cosmos eventually had to plead guilty to its laws. Number 4. Math versus metaphysics. Aristotle philosophized nature with rich metaphysics, causes, purposes, and essences, while Galileo brought a new swagger. The book of nature is written in the language of mathematics. Out went qualitative, lightness, and heaviness as explanations. In came measurable quantities, distance, time, angle, and relationships crisp enough to draw as graphs. By turning messy motions into uniform accelerations and law-like curves, Galileo swapped why talk for how much talk, building models that predict instead of pronounce. It's not that metaphysics vanished, it just stopped pretending to be a ruler and became a spectator while math, measurement, and logic ran the game clock of reality. Number 3. Telescope trouble. Pointing a spyglass at the heavens was the 17th century equivalent of turning on the lights at an awkward party. Suddenly everyone could see what tradition preferred to keep blurry. Galileo's telescopes revealed the moon's mountains, farewell perfect spheres, sunspots, so much for incorruptible heavens, and Jupiter's moons, cue geocentric model awkward cough. Add the phases of Venus and heliocentrism scored serious receipts. Aristotle's cosmos had relied on tidy, earth-centered harmonies. Galileo's optics hauled in raw, empirical b-roll that didn't match the script. It wasn't just stargazing, it was evidence gathering, and the sky, once a poem, started behaving like a dataset. Number 2. Inertia Revolution. Aristotle claimed objects need a push to keep moving. Stop pushing and the motion stops because that's just how nature is. Galileo took a smoother path, literally, using inclined planes to peel away friction's sticky fingers and glimpse a world where motion continues unless something interferes. He reframed rest and motion as two faces of the same coin, introduced frames of reference, and turned the forced motion story into inertia's calm rule. Left alone, bodies keep up whatever straight-line uniform thing they're doing. This quiet idea detonated loudly later, powering Newton's first law and giving the universe permission to coast. Number 1. The Falling Feud. Aristotle's take. Heavier objects fall faster because, well, heaviness. Galileo's reply. Let's test that, on ramps, with water clocks, and, legend has it, off towers. He showed that, neglecting air resistance, all bodies share the same acceleration, distance scales with time squared, a clean mathematical heartbeat under gravity's drum. The coup de grace was methodological. Don't trust how motion feels, isolate variables, measure, and let numbers talk. From Pisa's lore to precision timing, the feud settled decisively in favor of acceleration's universality, and the world discovered that gravity doesn't play favorites, it plays by laws. From armchairs to apparatus, from purposes to proofs, Galileo's showdown with Aristotle didn't just change answers, it changed how we ask the questions. Modern physics was a mic drop.